All right, in this lesson we're going to take a look at the quadratic formula. And what the quadratic formula is it's another method that we can use to solve quadratic equations. So by the end of this lesson, we hope to be able to use the quadratic formula to solve for the roots. And by roots, we mean the solutions or the x-intercepts of a quadratic equation if it is possible, because it's not possible to solve in all cases. So just as a bit of a review here, if we have a quadratic equation that looks like this, we know it's a quadratic equation. We know it's quadratic because we have the power of 2 on our x there, and we know it's an equation because we have the equal sign. If we were asked to solve this thing, we've been doing this for a while now. We know that we would take this and we would factor it. We've got it all set up here with all of the terms on the left-hand side and 0 on the right-hand side. So we would find our two numbers that multiply to 6 and add to 5. We could have an x and x here, and we have plus 2, and we have plus 3. So this is it in factored form. And then we would get our solution. So we know that we're going to take each of these things, set them equal to 0. One solution is going to be x equals -2. And another solution here is going to be x equals -3. And working from this, we know that if instead of having that quadratic equation, we had the quadratic function or the quadratic relation y equals x squared plus 5x plus 6, and we were asked to find the x-intercepts, we would do the exact same thing. We would factor it. We would set each of the factors equal to 0. So we would know that our x-intercepts would be at x equals -2 and x equals -3. Because these two questions of solving a quadratic equation and finding the x-intercepts of a quadratic relation are really the same question. The quadratic formula gives us another method to use besides factoring to solve these types of problems. So here is our quadratic formula. For a quadratic equation, ax squared plus bx plus c equals 0, where a does not equal 0, because if a was 0, it wouldn't be a quadratic equation, the roots, or the solutions, can be found by using the quadratic formula. And here it is. X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So basically all we're going to be doing is from our quadratic equation, we pull out the values of a, b, and c, we sub them into this equation, and we work out what x is going to be just by evaluating. There are some tricks that go along with it, which we are going to discover as we go along. So first off, let's just use this quadratic formula to solve the question that we just solved by means of factoring. So we've got the same equation here, x squared plus 5x plus 6 equals 0. Let's start by figuring out what our values of a, b, and c are. A is the coefficient on the x squared term, so that's just going to be 1, because this is like 1x squared. B is the coefficient on our x term, it's going to be 5. C is this constant at the end, so C is going to be 6. So our quadratic formula, x equals -b plus or minus square root of b squared minus 4ac, all divided by 2a. We're just going to take those values of a, b, and c, and we're going to sub them in. So I'm going to start by just putting brackets everywhere we have either a, b, or c, as we normally do when we are doing substitution. So what goes in each bracket? Well, we're going to sub in b here, we're going to sub in b here, we're going to sub in a, we're going to sub in c, and we're going to sub in a down here. So let's just make those substitutions. B is 5, B is 5 again, A is 1, C is 6, and A down in the bottom is going to be 1 again. Okay. And now we're going to start evaluating this. So we're going to do order of operations as we're doing our evaluation. So first off, this negative, then 5 in brackets, is just going to become a -5. we're going to keep the plus minus, and if you're worried about this plus minus, we're going to talk about what that means in just a minute here. So underneath the square root, we can do 5 squared, which gets us 25. We can do negative 4 times 1 times 6, which is going to be negative 24. And then in the bottom, 2 times 1 is just going to give us 2. Then we'll have negative 5 plus or minus 24. 25 minus 24 is going to be root 1 divided by 2. And of course, root 1 is just going to, square root of 1 is just going to be 1. So this is really negative 5 plus or minus 1 all over 2. Now it's time to think about what this plus minus really means. What this means is when we've been working with quadratic equations, we've seen that they often have two solutions. So the plus minus gives us the way of getting our two solutions. For one of our solutions, we're going to evaluate this expression using the plus sign. And for the other solution, we're going to evaluate the solution using the minus sign instead. So for one of them, we're going to have x equals negative 5 plus 1 divided by 2. And the other one is going to be x equals negative 5 minus 1 divided by 2. And then we're just going to evaluate these two things. Negative 5 plus 1 is negative 4. Negative 4 divided by 2 is negative 2. So there's one of our solutions. X equals negative 2, just like we had before. And then negative 5 minus 1 is going to be negative 6. Negative 6 divided by 2 is negative 3. So there's our second solution, x equals negative 3, just like we had when we did it by factoring. So this is how the quadratic formula works. We just sub in the values of a, b, and c, and we end up with our two solutions, one using the plus sign in the middle and one using the minus sign in the middle. Now, are there ways of making this a little bit more reliable as a calculation? Here's what I'm going to suggest. If we look at our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, we notice this little part underneath the square root, b squared minus 4ac. I'm going to bring that out and make it a separate calculation. And I'm going to say that this is equal to d because I have to make it equal to something here. So this value, b squared minus 4ac, or d, is called the discriminant of the function. And it actually gives us some information about the roots, or the solution, to the equation. If the discriminant is greater than 0, the equation has two real roots, just like the one that we just did. If the discriminant is equal to 0, so b squared minus 4ac equals 0, the equation has one root, which is sometimes called double root, or one solution. If the discriminant is less than 0, the equation has no real roots. The roots would be complex numbers or imaginary numbers. And this is because if d is, let's say it's something like negative 5, and we put it under the square root, we'd be taking the square root of negative 5, and this is not possible. Well, it is possible for complex or imaginary numbers. It's not possible for real numbers. So when you're evaluating or applying this quadratic formula, sometimes it's easier to do the value of that discriminant first, just to see what your solutions are going to be before you do the full calculation. So let's look at one here, x squared minus 6x plus 4. First thing we're going to do is pull out our values of a, b, and c. A is equal to 1, b is equal to negative 6, and c is equal to positive 4. So first thing I'm going to do is calculate b squared minus 4ac. And I'm going to do that just like I did in the last one, we're just going to do that substitution. So we're going to have b squared minus 4 times a times c. Just sub in b, a, and c. Okay, our b value is negative 6, our a value is 1, our c value is 4, and so we can start to evaluate. Negative 6 squared is negative 6 times negative 6, that's 36. This is going to be 36 minus 16, which is going to be 20. So the fact that this is greater than 0 means that we have two solutions, or two roots. Now we can go ahead and use the rest of the quadratic formula to figure out what those two solutions are. So the rest of our quadratic formula is x equals negative b plus or minus the square root of that b squared minus 4ac. So I'm just going to put that whole thing under the brackets and then 2 times a. So just filling this in, this was b here, this was a down here, and underneath this square root we're going to put d, or b squared minus 4ac is going to go underneath there. So our b value is negative 6. Our value for b squared minus 4ac, or d, was 20, because we just calculated it right here. And our a value was 1 again. So we can proceed as we did before. Start to simplify. Negative 6 is going to be positive 6, plus or minus. Square root of 20, I'm just going to put this into my calculator and get 4.47. Okay, 2 decimal places is fine. And all of this is going to be divided by 2. Now we're at the point where we can deal with the plus and the minus. So I'm going to split this up. I'm going to have one solution that is x equals positive 6 plus 4.47 divided by 2. And I'm going to have another solution that is 6 minus 4.47 all divided by 2. Okay, my positive solution and my negative solution. And then I can evaluate each one of these. 6 plus 4.47 is going to be 10.47 divided by 2. We get 5.235. Our other solution, x equals 6 minus 4.47, 6 minus 4.47, and then divide that answer by 2, gets us 0.765. So these are our two solutions. Now notice that these two solutions are x values that they're decimals. We wouldn't have come up with these by factoring. So this is a quadratic equation that we probably couldn't solve by factoring. The quadratic formula gives us a way of solving these things. Okay, let's just do a couple more here to make sure we've got a handle on this. So our next one here, 4x squared plus 12x equals negative 9. Now, our first step here is going to be to get everything over on one side of the equation and get 0 on the one side. So we're going to add 9 to this side, add 9 to this side to get 4x squared plus 12x plus 9 equals 0. Okay? Our quadratic formula, and factoring for that matter, only work when we have all of the terms in our quadratic on the one side and 0 on the other side. So let's go ahead and apply our formula here. A is 4, B is 12, C is 9. Let's start by figuring out the value of that discriminant b squared minus 4ac. So b squared minus 4ac. Our b value is 12. Our a value is 4. Our c value is 9. 12 squared is 144. 4 times 4 is 16. 16 times 9 is 144. This works out to be 0. Using that list of rules, we have one solution. Okay? And why we have one solution, we're going to see as we do the rest of our solution here. So let's set up our quadratic formula. Negative b plus or minus the square root of that thing that we just calculated, b squared minus 4ac, all divided by 2 times a. So our b value is 12, our a value is 4, and this discriminant that we just calculated is just going to be 0. So when we break this up into our two solutions, we'll have negative 12 plus the square root of 0 is just 0 divided by 8. And we'll have x equals negative 12 minus 0 all divided by 8. Notice in these two solutions that the numerator is going to be the same. Negative 12 plus 0 is negative 12. Negative 12 minus 0 is negative 12. So both paths, either the one using the positive sign or the one using the negative sign, are going to give us the same solution. So really, we're only going to have one solution here, which is negative 12 divided by 8, which is negative 1.5. And that's our one solution. All right. We'll look at one last one together, then I think you'll probably be ready to try one here. So we've got x squared minus 2x plus 7 equals 4. We've got to do the same thing we did last time. We've got to get rid of the 4 on this side by subtracting 4 from both sides and get this to be x squared minus 2x plus 3 equals 0. Now we're ready to apply our quadratic formula. A is 1, B is negative 2, C is 3, and let's start by figuring out the part under the square root, b squared minus 4ac. So b squared minus 4ac, negative 2 squared minus 4 times 1 times 3. Negative 2 squared is going to be negative 2 times negative 2, so that's going to be positive 4. Negative 4 times 1 is negative 4, times 3 is negative 12. This is negative 8. So immediately, we know that we have no solutions. Okay, and if I'm being mathematically correct, no real solutions. Again, for this reason, that if we apply this, put this into our quadratic formula, we have negative b plus or minus the root of d all over 2a. Our b is negative 2, our a is 1. We've got the root of negative 8 there, subbing d in under that square root sign. This is not possible. If you type this into your calculator, you will get a math error. Okay, so we have no real solutions. All right, try this one on your own. Maybe pause the video, try it, and then I'll do it and you can check your solution. So if I'm solving this one, I'm going to figure out my values of a, b, and c. C is negative 5. And then I'm going to evaluate b squared minus 4ac, which is going to be 9 squared minus 4 times 2 times negative 5. 9 squared is 36. 4 times 5 is 20. This is going to be negative times negative is going to give us positive, so 36 plus, sorry, not 36. 9 times 9 is 81. That's what strips me up there. 81, 22 is going to be what? 41. No, 40. Yep. And then, sorry, and it's going to be positive because the negative times negative gives us a positive. And then 81 plus 40 is going to be 121. There we go. All right, let's set up the rest of our quadratic formula here. We're going to have negative b plus or minus the square root of that thing we just calculated, all over 2 times a. B is 9, a is 2, and 121 under the square root. The square root of 121 is 11. So we're going to have our positive solution and our negative solution. Our solution using the positive sign and the negative sign, and one using the negative sign. negative 9 minus 11 all over 4. And so we're going to get here x is equal to 0.5. Negative 9 plus 11 is 2. 2 divided by 4 is 1/2, 0.5. Over here, we are going to get negative 9 minus 11 is negative 20. Negative 20 divided by 4 is negative 5. So those are our two solutions. X equals 0.5 and x equals negative 5.